All right, hello everybody. Welcome to the CS202 Computer Science 2 lab number 8. We're going to talk about overloaded arithmetic operators. What we're going to do is we're going to create a complex number class. So those are numbers that have a real component and a imaginary component. And we're going to go ahead and create a class called complex, and we're going to use their own header and C++ file. We're going to write a constructor that takes two doubles, one for the real, one for the complex part, and you'll notice over here we're going to do a default value, so that way we can initialize our complex number with just a single double. And then we're going to write a stream insertion operator to print out this complex number. We're going to implement an operator plus, so we're going to add two complex numbers together. We're also going to implement a plus equals operator, so we can add two of them together. And for the previous two steps, one of these we'll write in terms of the other. So more likely we'll implement plus, and then we'll use this operator within this one. We'll see how that works out. And we're going to test it. We want to make sure we can write this type of operation. So we want to see out 1 plus complex 2 and 3. All right, so let's go ahead and switch to the code editor. And over here I have, I'm using Sublime. I'm going to create a new folder. So this one is going to be called Lab 08. And we're going to need to create a couple of files. So we'll create complex.hpp. We'll make sure we put it in the right directory. All right. Complex.cpp. And main.cpp. All right, so those are our three files. We're going to go ahead and put some information at the top. So on the author, class is CS202. I know we're going to want the IOStream library. We're going to want to include our complex .hpp. All right, so there's our main, and what we'd like to do is create a little design. Here's the tasks that we want to do. So over here, create complex class. We need to be able to override the stream insertion operator, override the plus operator, override the plus equals operator, and I wonder if we had anything else. So we can just peek back here at the slides. I think those are going to be the two, those are the main tasks. Okay, so I think we're good. All right. So let's go ahead and start out by creating the complex class. So we do know that we want to be able to write something like this. All right. Now, of course, we know that's not going to work initially, but we're going to work on that. So first thing we need to do is get it working with just this line. So let's create our include guards. Create a class. This is our constructor, and we would like to be able to take a double for the real part and a double for the imaginary part. We also want to write a default constructor. Okay, and we'll go ahead and put some private members here. So this one we're going to have the real part, imaginary part, and we want these to be initialized to 0 when we first start out. Semicolon there, and let's write this definition here inside of our class. So complex.hpp. Imaginary and real. Let's actually go the other direction. Okay. So we should be able to, we're almost ready to test this out. But we're going to go ahead and mark that as done. We have the complex class created. And we're going to go ahead to our terminal. So there's our files. Let's add them. So create complex class. There we go. So checked in our work, and we're going to go back to our Sublime view. All right, so let's go ahead and implement this stream insertion operator. So standard OStream. We'll call it OS for output stream. And we'll take a const complex. We'll just call it C. Well, we'll just spell it out. All right, and we are going to need the IOStream class to get access to standard OStream. And let's go ahead and implement that. So if you remember from last time, we want to return a reference. That way we can continue to use it. And let's go ahead and print the imaginary part. And we probably want to make this look pretty nice. So oftentimes when you have imaginary numbers, they look something like this: x plus y times I. Okay, so we're gonna maintain that, or we could do I times y. Probably should find out. Just gonna look it up online real quick. A plus I times b. Okay. Okay, so this actually makes it easy. We're going to have our complex number plus I times our complex part. And if we wanted to, we can go ahead and make this. We can include the IO manip header, and we can use this to set the precision, or we can use it to print in a fixed format. We'll actually do that on the outside in the main.cpp file. So we can say cout standard fixed. All right, so there's our IO manip. Got our override there. So when we print this out, we should be able to print out these two options here. So just a regular complex number and a complex 2, 3. So let's see what happens if we compile this. All right. Oh, that's because we have not implemented the getters yet. So go back here and implement the getters. So double real part. This is a const because we're not allowed to modify this class. Same over here. Imaginary part. All right, so we can go back to the terminal view, compile that. Now we don't get an error, so let's run our output and we can see 0 plus I times 0, that's what we expect, and 2 plus I times 3. All right, so we'll go ahead and check in our code here. Lab 08, and the thing add operator. Okay, so go back to the code editor. That works. So now let's work on overriding the plus operator. So we can go ahead and write that in here. We're going to return a new complex number. The name of our function is operator plus, and we're going to take a complex number. Now, for something that's this small, where we're just passing two doubles, we don't really need to pass by reference. So we're just going to pass by value, and that'll probably be just as fast. So, and then what we're going to do here is do our implementation. And we're going to return a complex using the real part plus the complex real part and imaginary part plus complex imaginary part. All right, and so let's see if this is going to work with this line of code over here. If we just have one, let's see if the compiler is going to automatically detect that we should use this constructor because this second parameter is set to 0 by default. So let's try that out. So I'm going to switch to my terminal, and we're going to compile this. And it says operand types are int and complex. All right, so it doesn't know that that 1 is a double. So what we're going to do is we're going to adjust that in our main by writing 1.0 instead. And then we're going to switch back and see if that compiles. Okay, so operand types are double and complex. So it doesn't know how to do that. We would like to be able to do that. So let's go ahead and add a new operator. We have one that adds complex numbers. In fact, we can test that out real quick. We could say complex 4 and 5 plus complex 2 and 3. So we need to comment that out because we know that line doesn't compile. We run this, our program, and we could say 6 plus 8. So that's right, because we added 4 and 5 to 2 and 3. So 4 plus 2 is 6. 5 plus 3 is 8. So we know that we can add two complex numbers. So we're in the right direction. So let's go ahead, go back to the editor, and instead of having an operator that takes, we need to be able to take a double on the left-hand side and add it to a complex on the right-hand side. So we're going to go in here and we're going to write an operator It returns a complex number. So we're going to take a double as the left-hand side, and we're going to take a complex on the right-hand side. And so what we'll do is we'll return a new complex number, this time adding the left-hand side with the real part of the right-hand side, and we'll return the imaginary part for the right-hand side. Okay, so let's see if we can get this code then to compile. So we're going to go ahead and switch back to the terminal, compile. Okay, so we compile this code and we have multiple definitions. So if we switch back to our source code view, the reason for that is because we defined this function inside a header file. That means that it was included in complex.cpp and it was included in main.cpp, so two definitions. So there's an easy fix for this. When you have functions that are this short, we can actually turn them inline, and inline means that wherever it sees this function, it'll just go ahead and insert the definition of that function wherever it's encountered. And so this is a short one. This won't be a problem. So we'll go ahead and see if that fixes our compile error. Okay, so it compiles. Let's see if we get our results out. So we were adding 1 to a real 1 number to a complex number 2 and 3. So that appears to work. But does this work if you switched it around? In other words, does it work for complex 2, 3? We'll just change that to 4, 5 plus 1. We'll check and see if it works with integers as well. The compiler should take that 1 and turn it to a double. So if we switch to the terminal, I suspect that it can figure it out. So we run this one out. There we go. 1 plus 4, 5. The real part is added, and of course the imaginary part stays the same. All right, so I think it's safe to say that we can check off, the plus operator. All right, so we'll go back to our terminal, commit our work, and we have seen that the plus operator now works with a variety of different use cases, so pretty flexible. Now let's go ahead and work on this last part, which is overriding the plus equals operator. So inside our complex class, we're going to want to return a complex, except we don't want to return it by value, we want to return it by reference. So the reason why we want to return it by reference is because we'd like to be able to modify, or we're actually modifying that particular instance, and we want to return that instance of the class. Okay, so let's go over here to our implementation, complex reference, operator plus equals. So there's our other number we're trying to add. And remember, we want to return star this because we want to return this is a pointer toward the class. Star this is going to turn it into a reference type. So let's go ahead and apply this. So there's our real and our imaginary parts. And oftentimes when you're writing these like plus equals operators, you more or less are just applying the same thing component-wise to all of our member variables inside a complex class. All right, so this should handle our addition. So if we were to, we're going to test this last part. Let's create a complex number, and let's give it the value 7 and 8. And let's make another one. And we'll make this 10 and 20. And so if we were to print out complex 1, and we were to print out complex 2, then we can add 1, well, we can add complex 2 to complex 1. So now when we see out complex 1, we should see the values 17 and 28. That's what we're expecting to see. All right. So let's switch over to our terminal view. Compile our program. Run our program. We can see over here we created 7 and 8, 10 and 20, and we have added 17 and 28. So I think it's safe to say that we have completed our design tasks. So we overrode the plus equals operator. We tested each one. Everything works. So we'll just go ahead and commit this. Lab 08 override plus equals operator. Okay, so that's done. So go back to our slides and just kind of take a look and see if we did everything we were supposed to. So we implemented a complex number class in those 2 header files. We implemented a constructor which takes 2 doubles for the real and complex parts. Implemented a stream insertion operator. Implemented a plus operator for complex numbers, a plus equals member or a function for complex numbers, and well, let's see if we did this. Implement one in terms of the other. Oh, I don't think we did that. So let's go back and take a look at our code again. And let's see how we can modify this function. So instead of saying real plus equal, what we could do is we could say star this equals star this plus complex. And this should do the same thing. All right, so we have written this one in terms of this one. So let's see if that works. Let's go back to our terminal, compile, test, and sure enough, we this was 2 plus, let me go back here real quick. Yeah, this was 4, 5 plus 2, 3. This was 1 plus 2, 3. This was 4, 5 plus 1. We had 2 complex numbers, 7, 8, and 10, 20. And when we added them together, we got 17 and 28, and everything looks like it's working just fine. Okay, so we can even go back over here. Update plus equal operator. Okay, so it appears that now we have done everything. So we went back to our specification, made sure that everything's working according to everything as asked. This definitely works. So when we test in that program, it does everything we need to do. So feel free to work on your own complex class. You could maybe try doing subtraction in addition to plus equal if to get the additional experience. Anyways, I hope you have fun and have a good day. Adios.